Hi everyone, thank you for having me here. My name's Hannah and I'm from University College Cork in Ireland, and today I'm here to talk to you about Jelly Forecast, a short-term harmful jellyfish forecast for the salmon aquaculture industry, and this project has been co-supervised by Dr. Tom Doyle and Dr. Damien Haberlin. So why do we want to forecast harmful jellyfish? Well, we've heard a little bit today about aquaculture of jellyfish, jellyfish fisheries. Of course, traditionally there's a lot of aquaculture of finfish, so salmon aquaculture. And as you can see here from a couple of newspaper clips, jellyfish can actually be quite detrimental to this industry. They can cause kind of different mortality events and also some low-grade morbidities as well. There's a couple of different species that are problematic, such as the one here on the top, which is Pelagia noctiluca. Typically a more Mediterranean species, but we do see it in Ireland, particularly in the north. So in Northern Ireland, back in 2007, there was actually a really large fish kill there. Initially, numbers were over 140,000 salmon that were killed, but the total, after about a week, it was over 250,000. So essentially, the whole farm was wiped out in one go. And we also have other harmful species, such as the siphonophore Muggy atlantica, which is the species that I'll be concentrating on here today. This has been implicated in fish kills, not only in Ireland, but also in places like Norway, where over 100,000 salmon were killed at one time. So to look at where we are for this study, so we're in Southwest Ireland, and we're concentrating on the bays in Southwest Ireland, particularly Bantry Bay, and I've pointed out where the salmon farm, or one of the salmon farms that I have sampled at, is present. This bay has a long history of not just finfish aquaculture, but also shellfish aquaculture, and that's actually what kind of piqued our interest in it initially. Harmful algal blooms have been a problem here for many years as well, and there's been a long history of needing different mitigation measures to try and combat this for shellfish producers in particular. And also something that's interesting about this bay, the wind in Southwest Ireland, the prevailing wind is southwesterlies, and the bay is actually axially aligned to this wind pattern. So there's quite an interesting circulation that happens here during the summer months, and we'll kind of get into that more a little bit now. So in Bantry Bay, under kind of what we call normal conditions, typically we have a southwesterly wind blowing, which is aligned to the bay, as we saw on the last slide. That kind of pushes that top layer of warmer water up towards the head of the bay. So this is all happening during the summer months, so when there's been a lot of solar heating, the water column is stratified, so we have our thermocline there in the middle, and then we have our cold, denser water here on the bottom. So this is our typical conditions, and you have your offshore waters that's outside the bay. And then what happens is you get a relaxation, or sometimes a reversal of the wind pattern. So you might get a northeasterly or a strong easterly wind blowing, and that will actually be blowing almost directly out of the bay. And that's pushing that top layer of water back out, pulling in the bottom kind of cold, denser water, and shallowing the thermocline as well. And then what we've kind of dubbed as a flip-flop event, or what's an exchange event, I suppose, between the bay and the offshore waters. It happens then once you return to those normal conditions. So there's been a couple days of either relaxed or the opposite wind, and it reverts back to that prevailing winds. That's the main wind pattern returns, and you get an influx or kind of an exchange between the bay. I think it's up to about 70% of the bay waters become exchanged with the offshore waters, and that brings in any plankton. So what Rain et al. Had looked at with phytoplankton, we're kind of hypothesizing might be happening with harmful jellyfish blooms as well. So now how do we build on this? How do we create a forecast or a model? Well, we need to look at the correct time of year, which we've mentioned already. And that also is important for the zooplankton that are present. So Muggy atlantica occurs in Ireland not all year round. It's not a resident population. It only occurs in kind of the more summer months. So the kind of danger period, they call it, is more between June and the end of October. And you can see here just from Haberlin et al. Over the years, that's kind of typically been the case, where it's end of August, beginning of September, so almost autumn time really, where we start to see increases in the numbers of Muggy atlantica. Another thing is we need harmful gelatinous zooplankton data, so we need to go out and actually collect and ground truth this model and see what we think is happening. Is it actually happening? Is the jellyfish present? We then also need to look at wind data, so wind strength and direction. And we've from Rain et al., we've adapted their wind index that they use to try and pick out when these flip-flop or exchange events actually occur. And then along with that, we look at the fish mortalities data as well. So I'm actually doing this project in collaboration with a salmon seafood producer, Maui. So just a little bit of detail more on the methods then. So I've been going out since 2020 and taking triplicate zooplankton samples every 2 weeks. So that's over 78 different sampling dates over 4 years. The samples are collected every 2 weeks, as I said, or monthly in the winter when we know there's kind of less of the zooplankton around. You can see I'm pictured there on the top left, just beside the salmon farm. So that's actually where I sample. My station is right next to the salmon farm, approximately 100 meters away from it, just on the westward side, so towards the kind of bay side of it. And we also take environmental variables as well. We have a handheld CTD that we can take environmental variables to get our temperature and salinity and depth profile as well. And all of them collected, all the samples are collected with a 0.5 meter ring net with a 200 micron mesh and a non-reverse flow meter as well, so we can get those kind of more accurate densities of zooplankton. And just a little kind of more overview, I suppose, of what I'm looking at. I do look obviously at the harmful gelatinous, but we're also interested in all the other gelatinous zooplankton that are present. So over the 4 years, I've identified 32 different species or genera of gelatinous zooplankton from 179 samples, and that's all just within the one bay, Bantry Bay, that we showed earlier. And the highest number of different species recorded are January and August, with about 22 different species identified over the 4 years in August. And after Muggy Atlantica, and we'll come back to that in a little bit on the abundance, the next most abundant hydromedusae were Lysia blondina, with a peak at one point of 977 per meter cubed, and Aglantha digitale at over 300 per meter cubed. So now to kind of look at this model that we've developed. So we're kind of calling it a hindcast model. So we've collected our data. Now we're kind of retrospectively looking at the wind patterns and the wind directions and see, can we pick out these flip-flop events and can we correlate that with the zooplankton data that we've now collected? So what we're looking for, this wind direction data, is actually our axial wind, so that wind that's blowing in or out of the bay. We're looking for when that wind either reduces to zero or goes negative, which does happen quite a lot. But what we're also looking for is the wind speed or the wind index, and when that reaches a threshold that kind of Rain et al. Had put forward as probably the most likely when there's going to be a flip-flop event or an exchange event, is when that wind speed reaches over 10 meters per second. So you can see there's about 5 events there that do kind of meet those conditions. And then we have our zooplankton data as well. Now there's a little COVID symbol there just because, so we look at that window between June and end of October. Unfortunately, due to COVID, I wasn't able to start sampling until about the end of July, so we're just missing a little bit of data there. But we do know from looking at the historical data that generally Muggy Atlantica isn't going to be present, at least not in high abundances, till later on, so end of August, beginning of September. And so we can see that there. So we have our first event, no data, but pretty confident that we won't be seeing much Muggia. Then we have our second flip-up event there with the blue box and lined up with the red lines there. And it goes from virtually, I think it was less than 1 per meter cubed to over 100 or over 200 per meter cubed. So there's quite a sharp sudden increase in numbers of Atlantica. And then again, there's a second flip-flop and another jump. It had gone down and jumped up again. And you see kind of a little up and down there after that. Probably there is some kind of, in situ population growth at that point, and Muggy's been in the bay for quite a while. And then there's 2 more flip-up events later on, but we're kind of out of that period where Muggia is quite abundant, so we don't see any increases there. So 2021, we see kind of a different picture here. So in the last slide, we saw that there was a couple of flip-up events. This year, we don't see any that we really define as a definitive flip-up event. And we also see much lower numbers of Muggy Atlantica. The individuals per meter cubed reached only just above 40 per meter cubed, whereas before it had gotten to over 300 at one point. And we also can see from the way the Muggia increased, it was quite gradual, a bit more stepwise than before. There's not that sharp, sudden increase, and it wasn't preceded by a flip-flop either for 2021. And we do know from that year, we carried out a research cruise around the southwest coast, so outside of Bantry Bay, all around that kind of southwest coast of Ireland, and we saw pretty low numbers of Muggia that year in general. And 2022 is the last year I'm going to show you. We can see that there's kind of 4 different events that we've picked out here. There's some either quite strong, actually negative axial winds, and followed by increases in the wind index to above 10 meters per second. And we see this was a bumper year for Muggy Atlantica. There was Initially, there was nothing really happening until about mid-August, and then all of a sudden, it did increase to over 2,000 per metre cubed, reached a peak at one point of 3,000 per metre cubed. And I just have a little fish symbol in there because we did see an increase in mortalities following on from that increase. And yeah, then it kind of gradually disappeared again, and once it was outside that window, the flip-flops that did occur after weren't followed by an increase. So just to summarise all those findings together, so 2020 we saw 5 exchange events, 2 of which were followed by an increase in Muggy Atlantica. 2021 there was no definite exchange event that we could pick out, but there was a gradual increase in Muggy Atlantica. In 2022 there were 4 events, and 1 was followed by that really sharp increase in Muggy Atlantica to the highest numbers that we've ever recorded in Irish coastal waters. And just a key takeaway message, I suppose, is from what we're seeing, every sudden increase in Muggy Atlantica has been preceded by an exchange event that we can see in the wind index and the axial wind data. And so, following on from this, though we have successfully hindcasted some events using that same model that Rain et al. Has used for harmful algal blooms. Now we'd like to incorporate more detail, so we want to incorporate a hydrodynamic model with outputs of surface and bottom velocity flows. You can see just from this graph here, obviously the circulation that I showed you earlier is quite a simplified version of what's happening. Of course, there's little eddies here at the start of at the beginning of the bay. The circulation actually goes in a clockwise formation, so there's a lot more going on than just that simplified version, but that gave us a good proxy for the circulation in the bay. And then we want to run this in forecast mode, so eventually hope to have it potentially as an operational bulletin, much like the HAB bulletin that's available now for aquaculture in Ireland. So thank you for listening. I'll take any questions.